So again, these are just a few more examples of reaction predictions. If you feel like you've got this after you watched those videos that came before, there's no need to go through these necessarily, but I just wanted to give you a few more examples if you feel like you need it. So we're going to work through these pretty quickly. First one is sodium hydroxide is heated. So if you're looking at these, that's the only information that it gives you. And in this case, the only compound or the only substance that's mentioned there is sodium hydroxide. And so I'm going to write the formula for that. Keep it in mind, those charges. I get this one from the periodic table. This one's on the polyatomic ion sheet. And it's heated. It doesn't say it's burning, so this is not combustion. This is just a decomposition reaction. I'll add a solid symbol there because this is an ionic compound. In general, they're going to be solids at room temperature. So this is also one of your special cases that we talked about. So a metal hydroxide decomposes into a metal oxide. So that would be sodium oxide. And again, I'm going to come up here to work on my formula. Sodium's +1. Oxygen, because of its position on the periodic table, has a -2 charge. So I'm going to switch those charges, make them into coefficients. It takes 2 sodiums to balance out the charge of that 1 oxygen. So my correct formula is Na2O. So again, metal hydroxides give me a metal oxide plus water. We'll assume the water is liquid. It could be in gaseous state. Sodium oxide would be a solid. And then the last thing I need to do is look at the balancing for this equation. So start with my metal. Sodium here, I have 1 on the reactants, 2 in the products. Looks like I need a 2 there. For hydrogen, with that 2, I've got 2 hydrogens in the reactants. I have 2 hydrogens in the products. And this 2 means I have 2 oxygens. I've got 1 and 1, so 2 oxygens for the products. So we're done with that one. Next example. Magnesium metal is added to a solution of potassium nitrate. So magnesium is Mg. The fact that it's metal tells me that it's a solid at room temperature. And I've got a solution of potassium nitrate. Potassium is a group 1 metal. So everything in group 1 has a +1 charge. And nitrate is on my polyatomic ion list. It's NO3 with a -1 charge, so they cancel each other out to give me KNO3. It tells me this is a solution, so I'm going to go ahead and write AQ there, which stands for aqueous. And now I'm going to look at my possible products. So it looks to me like this is a single replacement reaction because I've got a metal here by itself and then a compound. And so magnesium and potassium could potentially switch places. So I'm going to go to my activity series, and you've got a copy of it there that's linked for you. And again, potassium is combined with nitrate. Magnesium is wanting to take its place. So nitrate is going to stay with potassium, or is it going to trade for magnesium? And so we said you only trade up, you never trade down. So actually for this reaction, it's not going to happen. We're just going to write no reaction here. Because of the activity series, these two will not trade places. And again, our thing to remember is like replaces like. So I'm looking at the 2 metals that can potentially swap there. The nitrate stays as it is. All right, next one. Solutions of iron 3 chloride and lithium carbonate are combined. So iron is Fe, chloride is Cl. This tells me that iron has a +3 charge. Chlorine, being in group 17, has a -1 charge. Hopefully you remember that from chemistry 1. So I need 1 iron for 3 chlorines. So FeCl3. These are solutions. So they're aqueous. Lithium carbonate. Lithium is a group 1 metal. It's here on the periodic table. So that means it has a +1 charge. Carbonate is one of my polyatomic ions. It's CO3. It has a -2 charge. So when I switch those around, it takes 2 lithiums to get a +2 charge to cancel out the 1 -2 there. So my correct formula is Li2CO3. And again, these are solutions, so they're aqueous. In looking at my reactants here, I've got 2 compounds that are made of metal and a negative ion, non-metal in this case, but a polyatomic here. And so it looks to me like that's a double replacement reaction. So I'm going to just switch partners. So iron is going to go with carbonate. Now let's look at this. Iron is +3. Carbonate is -2. So I'm going to switch these charges, cross them over. It's going to take 2 irons and 3 carbonates to give me a +6 charge here and a -6 charge here. And again, you don't have to write all this out. I'm just trying to illustrate where this is coming from in case you're still a little shaky on your formulas. And that leaves me lithium and chlorine. And lithium is +1, chloride -1. And so it is a 1-to-1 ratio for that one. Now, for these, I need to look at my solubility chart. One of these will be soluble, one of these will stay in solution if this is one will be insoluble and one will stay in solution. So I'm going to look at the iron carbonate, and this is iron 3. So on my solubility chart, iron 3 is here, and I'm going to go down to find where it intersects with carbonate. It'll be easier to see from this side. So iron 3 carbonate is right there. It would be insoluble. So that's my solid. Lithium chloride. Lithium's here, chlorine's here, and it is soluble. So that's going to be aqueous. Calcium reacting with fluorine gas. So here you've got 2 elements, and so the only thing these guys can do is form a compound. Calcium's a solid, fluorine's a gas. So that's going to give me calcium fluoride. I'm going to look at my charges. So calcium is in group 2, so it's +2. Fluorine is over here in group 17, so it's -1. And so there's 1 calcium for every 2 fluorines. And this is your formula, not because it was F2 here, but because it does take 2 fluorines to cancel out your charge there. Ionic substances are going to be solids. Alrighty, 3 more. Just again, if you're good with this, you can stop the video now. If you need to see a few more, we've got a couple more. Natural gas burns in a Bunsen burner. So it tells you here the formula for natural gas, also known as methane, is CH4. You might think that this is a decomposition reaction because you've only got 1 substance that's mentioned to you, but this keyword tells you that it's a combustion reaction. So I'm going to add some oxygen gas to that from the air. And our rule for this is a hydrocarbon, so made of hydrogen and carbon. When it combusts, it's always going to give you carbon dioxide and water, both gaseous, because we've got a lot of heat going on there. You would balance that equation. Carbon's balanced. Looks like I need to put 2 in front of my water here. And then oxygen, I've got 2 there, plus 2 more. It's 4, so I need a 2 there. Strontium metal is added to water. So looks like it could be a single replacement. I've got a single element here and a compound here. And remember, water's a little bit of a special case. We said think about it as hydrogen hydroxide, H2O. I'm going to come to my activity series here and find strontium. It does react with water, replacing the hydrogen. So I'm going to get SR, and it replaces this hydrogen. So it's not just strontium and oxygen, it's strontium hydroxide. If you look at the periodic table, strontium is a group 2 metal, which means it has a +2 charge. And hydroxide has a -1 charge, so it takes 1 strontium and 2 hydroxides. So I'm going to put this in parentheses with a 2 on the outside. And hydrogen is replaced, so now it's single, but hydrogen is also one of your diatomic elements. So I'm going to make that H2. The strontium hydroxide likely in this scenario is going to stay dissolved in the water that's there. It could be a solid if you've got exactly the right conditions. Need to balance the equation. Strontium is balanced as of right now. I have 4 hydrogens on the product side, only 2 on the reactant side. So I'm going to put a 2 there. And I've got 2 oxygens, and that 2 gives me 2 oxygen in the reactants. So we're balanced. And finally, an aluminum wire is placed into a solution of calcium chlorate. So calcium is a group 2 metal, so it's +2 charge. Chlorate, ClO3, and it has a -1 charge. So when you cross over those charges to make them subscripts, I see that I need 2 chlorates to get 2 negative for my charge to balance out the +2. This is a solution. Looks like this is going to be a single replacement pattern. Aluminum and calcium would possibly trade places because they're the 2 metals. So chlorate is with calcium, aluminum's here, so this is going to be another no reaction. If it did react, I would get, of course, aluminum chlorate. They're just going to change places. But since the calcium is higher on the activity series, this one doesn't react. So, guys, I hope those examples were helpful for you. Just work through these. Like I said, I've got answers there for you to check yourselves. And we'll talk soon.